for me, different links. We will start with the Cairo VM in Go soon. Let me check. Peter. Cairo VM. Is YouTube. Uh, yes, there. Yeah, I think we're live. Marian else. I will send you the YouTube link of the Slack so you can check if someone has any question.
Okay, here I am. Yep.
I will share the link. Okay, I just share the link on Telegram. Just give me a minute. Okay, well, I think we can start. Uh, I suppose that not many people is live right now, but I hope that many people will watch this video recorded and uploaded on YouTube or Twitter. So thank you for watching the video. The idea, give me a minute. I have a problem with my audio there. Okay, there. Sorry. Um, there. Okay, so the idea for today is to make a short demo on how things are going with the Cairo VM we're building in Go. But before the demo, I will try to introduce what's the idea behind doing this. The main goal here was to build a new VM from scratch, uh, as the VM built in Rust was more like a copy from the one in Python. The objective while we built the other VM was to have a faster VM built with Rust. And the objective was that, but it wasn't built uh, with much conscious on what we were doing. It was like copying the things the one in Python had. So for this one, we did the things differently. We put much more effort on the documentation, and we think much more on the architecture and the different parts of the VM. So to make it like for others to train on how to do VMs and for ourselves also to train on how to do VMs. And of course, beside that, the idea of another VM is to add diversity. Uh, we want to add diversity in different languages, in different regions, and it makes the network more robust. Uh, but well, one of the main goals was okay, let's do VM from scratch because the design will be better for sure. So that was the idea. We've been working in this uh, a few months, but then we stopped, and in the last few weeks, I think 2 weeks, we retake the project to make it aiming to make it compatible with the standard Rush, which is the execution engine. We are not there yet, but we are aiming for that. Well, now I think that Javier is going to show you what we have.
Yep. Yeah. So the idea now is to go over, the project in general, what we have done, what we are doing now, how we test, just a sort of like a deep dive into the project. So I'll share my screen and I'll start going over it. Yeah. So can you see my screen? Okay. Cool. Yeah. So I'll go over. This is the README for the project. This is the Cairo VM Ingo. So I'll go over this README because it's sort of organized. We put everything here. So as Leon said, we started working on this, and we had the first milestone, which was it's right here. It was running Fibonacci slash factorial program. We completed that a while ago, and then we stopped for a while. That was our first milestone, and now when we returned like 2 weeks ago, the idea was to have the second milestone of like a full VM implementation, and to make it actually compatible with Stargate and Rust, so actually make it usable. So these are all the sort of like the items, the tasks we need to accomplish to make that happen. Some of them we've already finished, some of them we have not. So the idea is to go over that. So in the past 2 weeks, we've added built-ins. We didn't have those. So for those who don't know, built-ins are sort of like built like an optimization. Certain operations can be expensive, so they're done like separately by this concept of a built-in. We've implemented those. These are actually all the ones for Cairo 0. There's one extra one for Cairo 1, but that comes later. We've also implemented memory layouts. This is sort of related to built-ins. The memory layout is where you choose which built-ins the program's going to use, and some other constants that are used throughout execution. So we've added those. We've also added proof mode. Proof mode is sort of like an additional option for execution you might want to use if you want the Cairo code, the Cairo execution to be proven. It adds quite a few things actually, like padding the trace to be a power of 2 and a whole bunch of other stuff. We've added that as well. And in general, we've also documented a few of these things. We haven't documented everything, but we have documented quite a bit of it. In fact, the documentation is on this README below. You can check it out. It's pretty long, not finished yet. But yeah, those were the things we have done so far, and we'll go over the things we need later. But before doing that, I want to show how we test all of this. So, because the idea here is we need a full VM implementation, and this needs to do the same thing that the Cairo VM in Rust does. So we need a way to test that. So for that, I'll show real quick how we do that. So our main idea here, this is the repo, of course, this is the makefile for the repo. The main idea is what you'd expect. We have a huge list of programs, and our goal is to run them both with our Go VM and with our Rust VM, and make sure that everything coincides. So executing a program will usually output a trace file and a memory file. So you can see here we have all the programs in the Cairo programs folder. We compile them into this JSON file, and then we run them both with the Go VM and the Cairo VM, and that outputs these files, the memory and trace files for Go and the memory and trace files for Rust. This is all done by the makefile. So you can see here, for example, this is where we run in Go every single JSON file to generate the memory and trace, and this is where we run in Rust with the Rust VM every program as well, and that will output the memory and trace. And then we have a bash script that will go through every single one, goes to those directories. We do this for both normal execution and proof mode, and that's why we have two directories to make sure it coincides for both. But essentially what we're doing here is we're going through every single program, every single trace on memory file, and comparing them to make sure that they're the same. So this is for trace, and this is for memory. Comparing memory, we do it through a Python script, just because it's a tad more complicated, but the idea is the same. We're making sure that they're the same. Yeah, and this is automated. So the idea is that if anyone adds a program here to this directory, when they make a PR, when they add a new feature, anything, this automatically runs, and we run it on our CI. So the CI is running these makefile targets, which essentially run this script. So our CI is actually running all of this on every PR, and that's how we make sure we're on the right track. I can show it real quick here. So if you go, if you go to any PR and go here to the CI, you can see we're actually comparing to make sure. Yeah, so that's on the test side. That's how we test. It's pretty useful, pretty convenient. Yeah, and that's how we've been approaching the work so far, and that's what we've done. And now I'll talk a bit about what we're doing now, because this is sort of like the list of features, and at this point we've reached sort of like the biggest, at least in terms of how much development time it takes, the biggest feature to implement, which is hints, which is this item right here. So hints in Cairo are a way to, essentially they're an optimization, but they're a way to run code sort of like outside of the Cairo execution. In Cairo 0, it's just some Python code that gets run, but essentially never shows up. It doesn't show up in the Cairo trace, so it doesn't get proven. They're an optimization for certain operations that might be too expensive to do the usual way, so they're done through these hints. And this is a pretty long task, because what we need to make it run for StartNet in Rust is we need to implement every single whitelisted hint, which are the hints that are allowed to be used in StartNet. And those are about 180 hints. So it's a pretty big task, and that's what we're working on right now. And to organize all that, we made, you can see it here, but we made both a GitHub project and a list of milestones with all the tasks to implement every single hint. So this was phase one. We essentially organized it to make sure that, because some hints depend on others, so we've organized it so that no one ever got a hint that they couldn't implement because they were blocked or something like that. So this was phase one, which is completed. We're now on both phase 2 and 3. Phases 1 through 3 will finish the common library, which are all the hints necessary for the Cairo common library. Those are about, I think, like 80 or something. And after that, there's phase 4, which is basically non-common library. We haven't gotten that yet, but we will soon. Yeah, so these are the milestones. You can go in here, you can check they're all closed, but these were the issues, and you can check out their PRs and everything. And we're also we have the same thing in a GitHub project. So this is the essentially the Gantt, or I don't know, the board where we track all the tasks. Yeah, organizing this work was key because it's not super hard, but it's a lot of work. So that's how we organized it. Yeah, that's how we organized it, and I'll now show also what it means to implement a hint, because it's what we've been doing the past few days. But essentially, implementing the way hints work is, again, there's a list of whitelisted hints, and those are basically some Python code. So the way we do it, I'll show it on the here on the repo. The way it works, and this works the same way in the Cairo VM and Rust, is we essentially, when we execute, we match, whenever we see some Python code, some hint, we match the actual string, which is we match the string of the hint. So the hint is some Python code. We have that actual Python code as a constant here. And when we're running, if we hit a hint, we fall into this function, and we essentially just have a huge switch statement where we check which one it is, and when we hit it, we call the function that manages it. Usually it will take, obviously, the VM, and then sometimes some other parameters that relate to how hints work, where sometimes there are constants or variables that are sort of like outside execution that you need to keep track of, and those are those IDs here, and also these execution scopes that you see throughout. But they're all pretty similar. Usually, hints will just take some variables from IDs, from this IDs manager, then do the logic, and then sometimes return it if they need to through these IDs or other methods. And this is essentially what it takes to implement the hint. So whenever someone has to do it, they just look for the Python code for that hint, put it on. They put it as a constant here, and then they match it. They add it to this switch statement, and then they implement it through this logic. And to test it, they will add. So I can show an example PR, but to test it, they will usually add a program. Aside from unit test, they will usually add a program that actually uses the hint. So this is for the assert non-negative hint. That's actually the first one we implemented. We add the program. Adding it means we are already comparing the trace files and memory files, but just in case, we also have an actual test file where we run all the programs to make sure they don't error out. So we're running it here as well, and that's how we go about hints. They're all pretty similar. This is like, again, the work that needs to be done. It's a lot of work, but it's pretty straightforward. That was the work we are doing right now with hints. You can track it here. And that's where we're at. That's what we have done and where we are right now. And then we can also talk about what's left. So after hints, we're not quite done. There are a few things left to do to have the full VM and be able to connect it with Startnet and Rust, so that it can be used for executing transactions and all that stuff. This is the list. Although we don't need it if we want to execute things like if we don't care about Cairo 1, for example, or if we want to execute simple contracts, a few of these are not necessary. The most important one that we need to be able to actually plug it right now and do a test is this one. This is starting integration. As it says right here, we need two things. We need to be able to run from any entry point. So far, essentially what the VM does is it executes main for every program. We need to be able to say we want to execute this other function, because that's how contracts work. You execute other functions. And then we also need to track execution resources and run resources. This is sort of like this is how you track execution. Like, this is essentially how you track gas. If you want to track how much gas you have spent and how much you have left, and whether you went over it, everything. This is the feature that's needed. Yeah, so this is the main thing that's left that we will be tackling in the next few days as well. It's not a huge amount of work, but yeah, that's the main one. And then we can at least do a test plugging it to start getting Rust and check if it actually works and it behaves the same as the Rust VM. So yeah, so that's what's left, and that's sort of like the whole picture for the VM and Go. There are a few other things we want to add, especially this is not super important right now, but at some point we might care about performance, and we will add benchmarks. We might also add fuzzing to catch possible errors that normal tests don't. And we're also planning on finishing documenting. We've started documenting hints. There's still a few ways to go, but the idea is to also finish documenting what we have done so far. But yeah, that's sort of like the whole picture for the VM status.
Okay. Well, thanks, Gary. That was great. And I don't know if Mint or Marian, and if you have wants to add anything else.
No.
Okay. So from my side, neither do I. I think it was quite complete. I would say let's try to record a small video with the demo, but it becomes nothing short, so we become start running. And we'll share that video as we did a few weeks ago. Let's do that to complement this video. I think that's it. Right? Okay. Well, thank you. Thank you all for sharing, and see you. Bye bye.
Bye bye.